Hello everyone and welcome to this video in which we'll be solving a simple question from permutations and combinations. I'm calling it simple, but I found that this question, several students are having a difficulty in understanding how to approach the question, how to even begin with the solution of this question. And some students, on the other hand, are also being able to solve the question very confidently, but are arriving at the wrong answer. So why is that happening and how to solve this question? All of that put together, I'm going to be discussing in this video. So the question says that a person is tasked with dividing the natural numbers from 1 to 9 into 3 groups. And each group, of course, is going to contain 3 numbers such that the 3 numbers of each group should be divisible by 3. We have to find out in how many ways can this person accomplish this task. So what we need to do first initially is that we need to group the natural numbers from 1 to 9 based on what kind of results they will give when they are divided by 3, because the question is all about divisibility by 3. So let's see what are the different outcomes possible when we divide any of the first 9 natural numbers by 3. So either the number will be perfectly divisible by 3, which means it will be of the form of 3x. Or it will give me a remainder of 1 when I divide it by 3, which means it will be of the form of 3y plus 1. Or the number will be of the form of 3z plus 2. It will give me a remainder of 2 when it is divided by 3. These are the 3 different outcomes that are possible when I'm dividing a number by 3. So let's group the numbers from 1 to 9 into each of these categories. So of the form of 3x, perfectly divisible by 3 are 3, 6, 9. Perfectly divisible by, or giving a remainder of 1 when divided by 3 is 1, 4, 7. And last group, which gives a remainder of 2, are 2, 5, and 8. Now, what people generally are doing, what a lot of students are generally doing is they're trying to find out how many groups of 3 numbers can be formed such that the sum of the 3 numbers of that group is divisible by 3. So let's see what happens when we try to do that, when we try to find out how many groups of 3 numbers are possible such that the sum of the 3 numbers is divisible by 9. So how can we form that group of 3 numbers? Either we can pick all 3 numbers from the first group, or all 3 numbers from the second group, or all 3 numbers from the third group. So when I pick up all 3 numbers from the first group, of course, it will be of the form of 3x plus 3x plus 3x, or it will be of the form of 9x. Let me make it 9x1 so that it does not cause any confusion. If I pick up all 3 numbers from the second group, it will give me in the form of 3y plus 1 plus 3y plus 1 plus 3y plus 1, which means it will look something like 9y2 plus 3, which will be entirely divisible by 3. And if I pick up all 3 numbers from the third group, it will be of the form of similarly 9z3 plus 6, which is also going to be divisible by 3. So doing this, we can form 3 groups in which all 3 numbers, sum of all 3 numbers are divisible by 3. Which are the 3 groups? So one group is 3, 6, 9. Sum of 3, 6, and 9 is divisible by 3. Or the group can be 1, 4, 7. Sum of 1, 4, and 7 is divisible by 3. Or it can be the group of 2, 5, 8. So there are 3 different groups we can form when we pick up all 3 numbers from the same category, which give the same remainder when it is divided by 3. Or how else can I select the 3 numbers such that the sum is divisible by 3? One more way of selecting the 3 numbers is that I can pick up one number from each group. Why? Because when I'm picking up one number from each group, let's say that I'm picking up one number of the form of 3x, one number of the form of 3y plus 1, one number of the form of 3z plus 2. Then the sum of these 3 numbers will end up being 3x plus 3y plus 3z plus 3, which is also clearly divisible by 3. Let's see in how many ways we can do this. So if I have to create a group of 3 numbers like this, then the first number has to be picked up from the first group, which can be done in 3 ways. Second number can be again picked up from the second group, which can also be done in 3 ways. And third number has to be picked up from the third group, which can also be done in 3 ways. So 3 into 3 into 3, 27 more groups can be formed by picking up one number from each category. So in total, 27 plus 3, 30 groups of 3 numbers can be formed from the set of natural numbers from 1 to 9, the sum of which is divisible by 3. Now, what a lot of students are doing is that they are stopping here. They are saying that, okay, I can create 30 different groups of 3 numbers each, sum of which is divisible by 3, and that is what the question is asking. But sadly, that is not the question. See, the question is saying that this person has to divide the natural numbers from 1 to 9 into 3 groups. The most important point to focus upon here is that we have to figure out how to form 3 groups. Whereas each of these 30 cases are singular groups. Single groups of 3 numbers, sum of which is divisible by 3. So that's why 30 cannot be the correct answer. 30 is only how many groups of 3 numbers we can form such that their sum is divisible by 3. Whereas I have to figure out how I can divide the 9 natural numbers into 3 groups. So then what a lot of students are doing is, they say that I know that there are 30 groups in which sum of all 3 numbers is divisible by 3. And I have to select 3 of those groups. So maybe the answer is 30C3. Now this also ends up being incorrect. Why? Because again, this time we have to focus on the fact that we have to divide the natural numbers from 1 to 9. Divide the natural numbers from 1 to 9 means that every number from 1 to 9 can only occur once across all 3 groups. And inside the 30C3, there is one group in which I have got 369. Maybe another group in which I have got 147. But there is also another group in which I have got 348. Problem is that 3 has already been picked here. And 4 has already been picked here. So I cannot divide the first 9 natural numbers into these 3 groups. Because every single natural number from 1 to 9 can be only present once across all 3 groups. Because the 9 numbers have to be divided, which means every one of these 9 natural numbers has to be a part of one of these 3 groups. That's why both 30 is incorrect and 30C3 is incorrect. So the question arises that how do we solve this question? Okay. So how we should solve this question is that we need to remember that we can make 3 groups in which all numbers from 1 to 9 are being used in 2 ways. Either, first way is very simple. First way we have already discussed. Either the 3 groups are 369, 147, 258. So we do this. This is one case. So we have used all the numbers from 1 to 9 and we have divided them into 3 groups. And the 3 numbers in each group, their sum is divisible by 3. So this is one singular case. What are the other cases? The other case is when in the 3 groups, I've got 3 numbers. The first number is from the first group, second number is from the second group, third number is from the third group. Similarly, in the second group also, one number is from the first group, one number is from the second group, one number is from the third group. And same thing for the last group as well. One number from the first group, one number from the second group, and one number from the third group. If we can divide the 9 numbers into 3 groups like this, then that also satisfies the condition given in the question. So this becomes a grouping and distribution question, that every one of the 3 number groups needs to have one number each from the 3 categories that we had created. So first category is the numbers are perfectly divisible by 3, which means that if one of the groups has got 3 in it, then the other group needs to have 6 in it, the other group needs to have 9 in it. Right? Now, based on this, let's try to find out in how many ways can I select the numbers from the second group to put into these 3 groups. So the second group has got 1, 4 and 7. So out of 1, 4 and 7, all 3 numbers are possible here. Only remaining 2 numbers are possible here. And only remaining 1 number is possible here. So out of 1, 4 and 7, I can fix 1 number here. Now there are, say, 2 numbers left. Out of the 2 numbers, I can fix 1 more number in the group containing 6. And then in the third group, I can fix the remaining number from among 1, 4 and 7, which has not yet been selected. So which means that the second number or the number from the second category in the 3 groups can be selected in 3 into 2 into 1 is equal to 6 ways. Similarly, the number from the third group in each of these 3 groups can be selected firstly in the first group in 3 ways, because out of 2, 5 and 8, I can select any one. Out of the remaining, I can select remaining 2. I can select any one for the second group, and the remaining number has to be gone into the third group, which means the number from the third category for each of these groups can again be selected in 3 into 2 into 1, 6 ways. So total number of ways of filling the groups of making these three groups will be 6 into 6, 36. So 36 more ways in which I can divide the 9 natural numbers into three groups such that the sum of the three numbers in each group is divisible by 3. So 36 cases here, one case here. So 36 plus 1, 37 total ways in which the 9 natural numbers from 1 to 9 can be divided into three groups. The sum of the three numbers in each group divisible by 3. I hope this clarifies a lot of your questions. Thank you.